let's get started. So let us briefly introduce ourselves real quick. So my name is Junmo. I'm a software engineer and also a founding engineer at Friendly AI. I did my master's and bachelor's degree in computer science at Seoul National University, especially working on deep learning system optimization. And I'm keep working on inference serving optimization at Friendly AI. And in here, we also have Ji-yoon, who's also a software engineer at Friendly AI, and he's working on agentic AI system focused on intelligent retrieval and ranking system. So let's get started. So let me briefly introduce what Friendly AI does first. So at Friendly AI, we provide you a GPU platform to accelerate generative AI inference. So if you have your own custom fine-tuned model or open source model and you want to use it in your own service, we can help you easily deploy those models and accelerate the inference performance and enjoy the lower inference cost. And throughout this workshop, I will cover why optimizing inference is important when especially building AI agents and how Friendly AI can remove your burden in inference. So here's the outline. So I will start with some background to explain some key challenges in running inference for AI agents. And after that, I will show you how our inference runtime handles those challenges. And finally, Ji-yoon will lead a hands-on session to build an interesting AI agent together using friendly endpoints. So let me start with why inference can be a bottleneck when building agentic AI. So as you already know, today, AI is not just about generating text or images. So we are building agentic AI system that can plan and also manage memory and sometimes call API by itself and orchestrate some complex workflows. But this requires multi-step inference. So in the agentic AI system, model can reason and execute and retrieve data, then reason again and again until it gets the final answer or accomplish users' final goals. So when building AI agents, model inference is involved in majority of parts of agentic AI workflow. So for example, the model inference is required to first understand user's intention and generate the tool arguments and parsing the tool outputs, and then plan next step and like repeat this cycle again and again, produce the final response. And it means that we need lower latency, higher throughput, and cost efficiency in inference because this kind of agentic AI system needs longer session, numerous model calls, and tool orchestration. So far, I've just talked about why inference is primary bottleneck in agentic AI workflow. And when we look a bit deeper inside, the real problem is the inference process itself is very slow and expensive. So it is slow and costly because, as you know, large models must process huge amount of data each step using hardware accelerators like GPUs. And there are two steps like prefill where input tokens are processed in parallel and decoding step where tokens are generated one by one or autoregressively using like stored KB cache status. And without any special optimizations, the model generates output one token at a time, and each token requires a full forward pass through the model's billions of parameters. So what we want to achieve in terms of inference is we want to keep the original model quality as is while getting lower latency and higher throughput. And to achieve this, various kinds of optimizations are required, so as listed in this slide. But but here's the reality. So as a developer and founder of the service, what we don't want to care this kind of low-level details. What we want is just we want to make our service fast, efficient, and reliable without any kind of engineering overhead related to this kind of optimization matters. So that's what Friendly AI take care of. So with Friendly Inference, you don't need to worry about complex optimization spaces by yourself. So yeah, so at Friendly AI, this is our approach for the optimization. So we will keep model quality as is, and we consider the trade-off by considering the trade-off between the performance and also consider the context of your own application scenarios, and will provide the best option for your cases. So various kind of inference optimization listed so far, such as batching, scheduling, quantization, KB caching, speculative decoding, that kind of things comes together in our own inference runtime, which is called Friendly Engine. So we built this inference engine designed from the scratch to handle the demand of various kind of Gen AI workloads, including language models or multimodal models. As you can see in this architecture, the inference server first receives incoming requests, and the model executor runs them using our internal IR and DNN libraries. And at runtime, Friendly Inference dynamically applies all the techniques that I aforementioned to maximize the performance and efficiency. So let me quickly walk you through how our platform actually looks like. And one thing I want to mention first, so we are integrated with Hugging Face. So you can deploy like 450K models in Hugging Face right away. So for example, you can just select the model you want to try. And when you click the deploy button right top, there's a friendly endpoint. And you can deploy this model just a single click. Actually, 2 clicks. Yeah. So this will deploy the model. It can be your own. It can be the model that in your own private repository as well. So you can deploy this kind of model by yourselves, very easy. And we also have our own platform where you can do the exact same thing. So you can create a new endpoint by clicking this. So what you need to do is select the model. You can select it from Hugging Face, as I did before. You can select the model, or you can also select it from weights and biases or upload the model. And we provide a feature like online quantization. So you don't need to quantize the model by yourselves. We will do it on the fly when creating an endpoint. So you can lower down the precision as well. And what you need to do is just select the GPU instance type that you want to try, and we will also provide an auto-scaling option, which adjusts the number of replicas based on the real-time traffic. Yeah, this is the dedicated endpoint where you can deploy your own model, and we also have a serverless endpoint where some most trending models are pre-deployed so that you can just plug and play in your own service very easy. So yeah, and our API itself is OpenAI compatible. So yeah, you can use OpenAI compatible platform. You can like agentic platform very easily. So yeah, there it is.
Some cloud or?
Oh, so when you deployed the model, like the way I showed, then it will be deployed the cloud that we manage. So on our cloud. But if you want to use our engine in your own infrastructure, we provide you a container solution as well. Here it is. So you can we provide a Docker container image. So you can put it and run it in your own like a Kubernetes cluster by yourselves. That's another option that we provide. Okay, so yeah, as I mentioned, it's OpenAI compatible. You can use OpenAI SDK as is, and we also provide some tool assistant API. So for instance, if you want to leverage the web search tool, what you need to do is just adding type web search or some other built-in tools like this manner. Very easy. Okay, now let's move on to the hands-on session. So Ji-Yoon will handle this. So yeah, we have a Jupyter notebook, Colab notebook, so that you can easily follow the session. Yeah, please go to this URL or scan this QR code if you want to use your phone. So yeah, this URL, when you click this URL, yeah, let people do this first. Everybody ready? Can I? Yeah, I think everyone's ready. Yeah.
Hi, it's Jiyun Jong, and I'm gonna follow you to build a tool-augmented chatbot that runs on friendly serverless endpoints and using Hugging Face MCP server tools. So we're basically building a single agent that runs on friendly serverless endpoints and use tools from Hugging Face MCP servers. In order to follow this code, you have to first sign up for the Friendly account and redeem the free coupon. So I'll wait for you guys to sign up.
URL again, please.
I'm sorry?
Go to the URL again.
This one? Sign up?
Yeah, I missed the link. Can you go?
Ah, you mean the notebook links?
Take a picture of it and I'll share it with you.
Okay. I got it. Thanks.
You got it, I think.
If anyone else needs it, just let me know and I'll come over.
Yeah.
How to coupon? Ah, okay. So for the redeem coupon, if you sign up and then go to dashboards, you'll see the overview page like this. And then for redeeming coupon, you can go to subscription, billing, and redeem free coupon and type the code coupon that you have. It's friendly_1010.
All right, let's pause there. Make sure that everybody is caught up. All right, we have a question.
Well, not a question, but I need the link.
Oh, the link. Okay, we're good.
Anyone else need it? All set?
All right, and is everybody there with the free credit code? Anyone needing?
Friendly_1010. All capitalized.
Okay. Looks like we're ready.
So you have your Friendly account and also you redeem the free coupon. So you have $20 credits for each serverless and dedicated endpoints. So first, you need to install dependencies. These dependencies is what we need for this session. And then you also have to get Hugging Face and Friendly token. Oh. One more.
Great.
Oh, sorry about that. Okay, I guess you guys might have the tokens, and you have to just enter the tokens in this to set the environment variables for Friendly tokens and the Hugging Face token. So let's say you have all set this up. And this is MCP, a short explanation about what MCP is and how it works. So basically, it's a bridge between LLM and external tools. So through MCP protocols, LLM can access to external tools and use the tools to respond the wanted answers. And this is the workflow image that we're gonna go through today. So when user query requests to Friendly, it chooses the tools that some necessary tools to process this query, and then using the tool results and query, it respond to users, and it's all served by Gradio chatbot UI. So you guys will feel like just chatting with the chatbots. And this code snippets can check tools, how many tools that Hugging Face MCP can serve. So if you see there are several tools that can use. For today, I'm aiming to use model search tools to find right models for user. So basically, if user queries in natural language of model specifications, and then the LLM use this tool and then respond the right exact models from Hugging Face. And since as Yumo said, since our friendly endpoints is OpenAI compatible, we use OpenAI compatible client. So we have to adapt the Hugging Face tool definitions to match the OpenAI tool schema. So we have to delete some fields that OpenAI's tool schema doesn't support. So this function will do that, and we'll use it later. And for the next step, we have to configure the client. As I said, we're using OpenAI client, OpenAI compatible client. And then this is MCP client class which is like an abstract layer class that can connect to MCP server and then get tools for LLM. And then it's a chat predict function, which functions as a Gradio chatbot background logic. So configure the system prompt you want, and also the messages that you want. And then you have to configure the models, so you have to choose what kind of models do you want to use in order to get the response from them. So you just give them the whole tool set to LLMs and then queries and then system prompt. Then it will find out the tools they want to use. Then it will respond that what kind of I want this tools to users. And then we actually call these tools that are chosen by LLMs and then retrieve the tool result and append it to messages and then request it to LLMs again. So this type of loop keeps on tool calling, and then we get the tool results, and finally LLM will decide, oh, I don't need to tool call anymore. So then we get the final response from the models. And for last, this is a Gradio chat interface configuration code. And then if you run it, wait a sec. Yeah, you can see the chat interface here. So you can just request any like model search questions you want. Let's do it. Find models created by Google with over 10K downloads. And then our LLM friendly serverless endpoints will use the right tools that we offered, and it's using model search, right? And it will return you the whole model sets. So let's go to Gamma 3, 27 billions. And then you can navigate to Hugging Face model page, just like this. And the one thing I mentioned about this too is when you go to Hugging Face model page, you can click deploy button here and then go navigate to friendly endpoints to deploy the whole process of this. Yeah, this is what we handled before. Yeah, I think this is it for this session. And so we've seen through building a single agent using friendly serverless endpoints using the external tools from Hugging Face MCP. So thank you for joining the session, and I hope this session inspired you to build like cool stuffs on friendly serverless endpoints. Thank you.
Great. All right, so we give you a round of applause, but also you have 5 minutes left if you want to ask any or answer any questions. But also, you should pull up a screen that's dark for the picture.
Okay, thank you. So if you have any questions, can. Yeah.
How are you guys different from RunPod? Oh, so RunPod is a platform that can deploy a generic container image using a like a Kubernetes pod as a pod format, and we provide service more focused on the inference side. So RunPod, through the RunPod, you probably be able to deploy your own model by using open source serving engines such as VLLM. But we have our what sets us apart is we have our own optimized inference engine, which is way faster than VLLM. So that's the key value that we provide. Yeah, compared with RunPod, and we also we will soon release a feature very similar with the RunPod so that you can deploy any kind of like a generic container image through our platform as well. Yeah.
Any other questions? Okay, so we'll have them pull up a black background. So these are really cool monitors. They're really impressive. But if you have a white background on it, then there's these weird lines on it. So for their pictures, Oh, you have more to- oh, I'm sorry.
Actually, yeah, I want to say one more thing lastly. So yeah, we have for the if you are a founder of a new startup, which building a new cool things, you can apply for the $10K dollar inference credit by scanning this QR. So it won't take less than 2 minutes. So please feel free to apply, and if you qualify, you will get 10K credits. And yeah, please share your feedback through the QR code on the right. So yeah, that's all. Yeah, do you want me to talk?
Black background for pictures? I'll take pictures of you.
Yeah.
What do you mean? Oh, like a dark. So I saw on your.
Oh, okay. Sorry.
That's good. Yeah, all good. Nature.
Oh,
We'll go to their
something like that.
page and get.
Yeah, something like this.
Okay. Yeah. Okay. Move your arms. You're talking.
Ah, there's Alex too.
Good. You're good.
Yeah.
That's right.
Yeah.
Thank you.
Yeah. Thank you guys. Yeah.
Round of applause.
Thank you.